Students, this video is to help with the quadratic functions packet that was given out previously in class. I will be going over the answer to that, including a little bit of commentary about the topics at hand. So it's all about quadratic functions. First, I wanted to talk to you briefly about vertex, intercept, and standard form. These are the three forms that are talked about on this worksheet. The vertex form of any quadratic equation is going to have x minus h squared plus k. And keep in mind, h and k are just like a, b, and c, just like a and b here. They're just letters, like m and b for the y equals mx plus b format. They're just constants. The important part of this form is that it doesn't have an x squared itself, but it does have, in parentheses, x plus or minus some constant squared, and then a constant on the outside. That's how you can tell it's vertex form. Later on, we'll talk about this form in terms of what it means for the vertex and also what it means for we'll get there. The intercept form is also known as the factored form. This is the familiar AM method where you find two numbers that add together to the middle and multiply together to give you the third term. And this A and this B turn out to be the roots of the equation, right? So you could call it factored form, intercept form. Some people call it the root form, but I don't think that that's ever used like officially. And then standard form is the boring form, ax squared plus bx plus c. This is the only form of the quadratic equation that we use that actually has an x squared in it. Keep in mind this one has x times x is going to give us x squared, but it doesn't have x squared in it. This has x minus something squared. That's going to give us x squared, but it doesn't actually have x squared in it. The only one that has x squared in it is called standard form. All right, so going down the list, here are the correct answers. Those first two are in so-called vertex form. They have the parentheses and the squared on the outside. This third one is standard form because it's got the three terms. All of them have constants, a, b, and c. And then this third one is the intercept form because there's a number on the outside here in front, but the important part is that there are two roots here. There are otherwise known as the intercept, so intercept form. The last part is to find the vertex, and actually with vertex form, these two are in vertex form. It's actually quite simple to find the vertex. I'll show you the first one and the second one so you can see the pattern. First one, the vertex is, well, we see a positive 4 here. Notice that it became a negative 4. And we see a negative 3 here. It stayed negative 3. So when you have a function in so-called vertex form, you're able to determine the vertex by following this simple phrase. I call it inside inverse, outside same. So for the number that's inside the parentheses, we use the inverse. So positive 4 goes to negative 4. The number that's outside the parentheses is the same. So negative 3 stays negative 3. You also have another option. You could go into your calculator, put this equation into the calculator, and find where the vertex is by yourself. So I plug in x plus 4 squared minus 3 into the calculator. And if I go to well, first I'll look at the graph. On the graph, you can see that the vertex is a minimum. It's going to have the lowest y value. So I go to my table and look for where the lowest y value is. Looks like these are pretty high, but they're going lower. So I scroll until I see the lowest y value is negative 3. Negative 4, negative 3 is the vertex, which is the same one here. All right. Go away, calculator. Now let's talk about the second one. This is still an equation in so-called vertex form. So I have an inside number that's negative 2. I changed it to positive 2. And there's no number on the outside. There's no outside number, so that means the number is 0. So there's my vertex. Easy as 1, 2, 3. For standard form, there's a formula to follow, which is this. This formula is for finding the x value of the vertex, otherwise known as finding the equation of the axis of symmetry. So I'll just plug in my negative b, which is negative 6, over 2a. In this case, my a is negative 1. So it looks like this. You can simplify this even further by doing negative 6 and 2 times negative 1, which looks like this. So using this formula, I found out that my x value of my vertex was negative 3, so I know negative 3 goes there. I don't know the y yet, but I have an equation here, and it has x's and y's. So if I know the x, I can substitute that x in to find y. So here's how that looks. I'm going to clear this out a little bit. Write out my original equation, then I'll substitute the negative 3 into this equation, and then solve for y. So that work is going to give me eventually y equals 13. So I can say negative 3 comma 13 is my vertex. And then last but not least, for number 4, it gives me the equation, and there's a couple ways to do this. I could turn it into standard form and use this formula. I could turn it into vertex form and then find the vertex that way, or I could use my calculator. So let me show you how to use the calculator.
So the first thing I'm going to do is take the equation and plug it into my calculator, into the y equals menu. Then I'm going to look at the graph to take a look at whether it's a vertex at the top or vertex at the bottom. It looks like it's a maximum, right? It goes up and I can't even see the top. So it's going to be more than 10. So I'm going to go to my table now. And I'm looking for where the y value is right around positive 10. Oh, there we go. So it looks like the vertex is at 3, 12. It's the highest y value that there is. So my vertex is 3, 12. Please pi. All right, moving on to the next. It asks us to solve the function graphically. Graphically, of course, means using the graphing calculator. So I'm going to go to my graphing calculator and put in these new equations. And you might be tempted to say, well, since it says graphically, I'm going to click the graph button and try to graph from here. It's hard to graph using just the graph, like it doesn't give you exact points here, even if you like try to trace along using the cursor. Like it says, oh, this point is, 2.12 and 1.29. I don't want to try to guess. I want to get exact points. I'm going to go to the table, second graph. And I am going to try to graph all the points that I can. I can't graph negative 217, but I can graph negative 110, etc. So I'm going to graph them now. And you should see that once you start graphing parabolas a lot, you'll see that they have this symmetrical pattern where this one has the y value of 1, both of these have a y value of 2, both of these have a y value of 5. It's just going down and up, or sometimes up and down, using that same pattern. And I'll connect these together. Parabolas don't have to be as neat as linear equations because you can't use a straight edge for these. You just have to sort of put the curve to it and then, of course, label and put arrows. Next is this graph, which I'll show you now. You can see I put the equation into my calculator the same way that I see it. And then I'm going to go to first I'll go to the graph just to make sure I know what it's supposed to look like. It's supposed to be a U shape. And then I'm going to go to the table and graph all the points that I can. All right, here are the points that you can graph. Notice that this one is a little bit thinner than the previous parabola. And then we can connect these together with a straight line. Let's see if I can connect these here. Close enough. Arrows at the ends, and a label. Let's move on to the next part, which asks for vertex and solutions. Let's do vertex for this one first. You can see the vertex is here. It's also called the turning point. It's 2, 1. It is the lowest point on the graph. So the vertex is 2, 1. Moving on to the next vertex. It is also the lowest point on the graph. You can see that it's where the parabola turns. It's this point here, which is 1, -8. So that's the vertex 1, -8. Now for solutions, remember the solutions are also called the roots, and they're also known as x-intercepts, where the parabola touches the x-axis. It looks like for this parabola, it doesn't touch the x-axis. So there's no solutions or no roots. So you would type no solutions, or in your case, you would write no solutions. However, on this side, we can see that there is one root here and one root here. The roots are at -1 and +3. So we're saying the solutions are -1 and +3. And by the way, x equals -1, you knew that this was one of the solutions because one of the factors said x plus 1, right? It's the inverse of that sign. And then x -3, you knew that +3 was one of the solutions also. All right, that's the advantage of looking at the intercept form of the quadratic equation. Moving on to the next portion, which is on factoring. The first question says to factor completely. Actually, what I'll do is I'll show you the correct answers here, and then I'll talk about a couple of them. So go ahead and try these out, and then come back and see if you got them right. First one asks you to factor completely. So I use the AM method. I'm using AM method because there's no coefficient of the x squared, and it was easy enough to find numbers that multiply together to give you 8 and add to give you -9. Those numbers were -1 and -8. So x -1, x -8. This isn't asking us to solve, it's just asking us to factor, so we are done with this one. Take a look at the second one. Recall from previous videos, the GCF method is the first method you're always going to try in order to factor completely. So I see that 3 goes into both of these terms. 3 goes into 3x squared just once, and 3 goes into 48 16 times. So what we did after that was use the dots method. The difference of two squares, we took the square root of x squared, which is x, and the square root of 16, which is 4. If you need more information on GCF or dots method, I have another video on my YouTube channel, on this Squirting YouTube channel, about factoring. All right, next is this example, 16x squared plus 81. And for this one, you might have thought to yourself, oh, I'm going to use dots because 16 and 81 are perfect squares, and so is x squared. However, difference of two squares requires there to be a difference, so we cannot factor this one. I put LOL because you just can't factor it. Take a look at number 4. Here's another example of can you use dots or can you not? And the answer is you cannot. P is the common factor between these two, so we're going to try JCF method first. We factor out the P and we're left with 100P minus 49. Well, it turns out that this is not difference of two squares either because 100 is a perfect square, 49 is a perfect square, but P is not. So we can't take the square root of P. So we're going to have to leave it like this. This is a factored form. All right, moving on to questions 5, 6, 7, and 8. Here we go. This one is pretty straightforward. We use the AM method. We look for the numbers that multiply together to give you 21. Negative 7 times negative 3 is positive 21, so that means j minus 7 and j minus 3 are the two factors, right? Negative 7 and negative 3. They multiply to 21, and they add to negative 10. All right, we're skipping 6, 7, and 8 in favor of taking a look at section 2, which is graphing the quadratic equations. This section is actually pretty easy when you have your calculator, which we just so happen to have. Here, the equation is in vertex form, so let's throw that in the calculator here into the y equals menu. Don't forget that negative sign at the beginning of the parentheses. All right, I'm looking at the graph to just see what the parabola looks like. It looks like a sad face parabola, and then I'm going to go into the table to look at the points. Some of these points I can't graph. Negative 45 is a y value that I can't graph, but I can graph a lot of these other ones, right? So I'm going to graph these ones. All right, we have a parabola going here, and now I'm going to connect the points with a parabola. Beautiful. Let's get arrows on those and a label. While we're here, let's take a look at the rest of it. It's asking for vertex, intercepts, etc. Let's do it one at a time. The vertex is the point that's here. Let me highlight it here. This is the vertex here. It's the point that is either the maximum or minimum point. Easy for you to say. That point is negative 3, positive 4. It's looking for the x-intercepts, otherwise known as the roots. The x-intercepts are going to be here at negative 5, 0, and here at negative 1, 0. So those are the x-intercepts. The next thing asks for the axis of symmetry, and the axis of symmetry is the straight vertical line that goes through the vertex. This is the axis of symmetry. We name any axis of symmetry, any vertical line, by x equals where it touches the x-axis, x equals that point. So this is x equals negative 3. We also know that the axis of symmetry is x equals negative 3 because the x value of the vertex is negative 3. So x equals negative 3. Next, the question asks for the y-intercept. That's where the x value is equal to 0. We can look at the table for that. X is 0 when y is equal to negative 5. So that's the y-intercept. We can also see it on the graph here. The y-intercept is going to be on the y-axis. So that's this point here, which is 0, negative 5. The next part asks us about the domain, which, as you know, is all x values, and the range, of course, is all y values. So in this problem, it's asking which x values are used, and it turns out that you could use any x value that you want. In fact, if you scroll up and down infinitely, the x values are going to continue because this arrow indicates it's going downwards in the negative direction, but it's also going outwards this way. See how it's not directly downwards, it's sort of going out this way. You can use any x value you want in this problem, and it'll still give you a value for y. So my domain is all possible x values. So the way that we write that in math looks like this. That phrase, all real numbers, that indicates that any value can be used at all. There's no restrictions on what x values can go in there. Think about it like this. What values can I substitute in for x? Can I put in a fraction? Sure. Can I put in a decimal? Sure. Any positive or negative number? Yeah, absolutely. Any number you can put in here. Moving on to the y values or the range, you can see that the y values keep going infinitely downwards. However, they don't keep going infinitely upwards. They actually stop right here. This is the highest y value you could possibly get at y equals 4, right? 1, 2, 3, 4. So I can say that my y values, my range, is all numbers that are at 4 and below. So here's how we write that. Y is everything that's less than or equal to 4, right? Starting at 4 and going downwards. It can't ever go above 4. The next part asks us where it's increasing, it's where it's decreasing. So let's take a look at the graph for a moment. I can see that from this point all the way up until the vertex, it is increasing, right? It's going up from left to right. The values are going upwards. However, stopping here, now it starts going downwards, right? So from here, it is going down in the negative direction. So it's increasing up until x equals -3, and it's decreasing after that. So we can use that information to write out where it's increasing and where it's decreasing. Here's how we're writing this out mathematically. We're saying it's increasing from -infinity all the way up until -3 for all x values in between -infinity and -3. So from here all the way upwards, stopping at -3. And then it's going to be, let's see, it's supposed to be decreasing from here until positive infinity, until x becomes positive infinity, right? So starting at -3 and going up to positive infinity. So the decreasing is going to look like this. So notice that from -infinity up until -3, that's when the x value is increasing. I'm sorry, that's where the y value is increasing. And when x is going from -3 to positive infinity, that's when that y value is decreasing. Okay, let's take a look at the next parabola. Once I substituted the equation into my y equals menu, I went into the table and I got the points and I was able to graph those points. Here's what the parabola looks like. All right, now we can identify all the other stuff. Here's the vertex, which is the lowest point on the parabola. That is 1, -4. Here are the x-intercepts, which we can find by looking at where the parabola touches the x-axis at -1, 0 and 3, 0. And now we're looking for the axis of symmetry. We don't need to look up here to find that. We could just use the x value of the vertex. So the axis of symmetry should be x equals 1. And next it's looking for the y-intercept. That's the point at which the parabola touches the y-axis. That's at 0, -3. And again, it's asking for domain and range, which is all the x values and all the y values for basically every quadratic equation. I don't want to say every single one, but I think every one that we're going to be dealing with in this class, the domain is going to be all real numbers, because every x value that you put into this equation, you're going to be able to get a y value out. So the domain, again, is all real numbers. If you had to ever guess as to what the domain is for a quadratic, it should be all real numbers. All right, for the range, in this case, the range was all values that are 4 and below, because all of these values were below 4. For this one, all of the y values are going to be above a certain value because we have a minimum here. The minimum here is -4, right? So starting at -4 and going upwards. So instead of saying y is going to be less than or equal to 4, I'm going to say y is greater than or equal to -4, because that's the lowest y value, -4. And let's do the increasing and decreasing. From this point all the way up until -4, x equals -4, it's going to be decreasing. So my decreasing range is going to be from, let's draw it in here, let's use green. My decreasing is going to be from all the way from -infinity all the way up until until +1, right? So all of the x values, right? From -infinity all the way up until +1. And then for increasing, we're starting at x equals +1, and we're going further and further upwards on the x values, right? We're going further and further forward on the x values until we reach positive infinity. So I'm starting at +1 and ending at positive infinity. All right, those are those blanks. Now let's take a look at the maximum, the minimum, and the solutions. Maximum and minimum values of functions. Well, if I'm looking at this function, I can see that it has a maximum value. And when we're talking about the value of the function, we're talking about the value of y. So the maximum y value is here 4. So my maximum value of the function is y is equal to 4. That should be in red. And then the minimum value of the function, notice that it keeps on going towards -infinity. It never stops. So there is no minimum value of the function. We're going to say no minimum. And then for the solutions, we already know that the x-intercepts are -5, 0, and 1, 0. So the solution should be x equals 5. I'm sorry, -5, and x equals -1. Now the other graph, you can see that it does have a minimum, right? It has a lowest value, which is the y value of -4. However, it doesn't have a maximum because it goes upwards towards infinity. So I can say that there is no maximum, but the minimum is -4. And similar to the previous one, the solutions are where it touches the x-axis, otherwise known as the x-intercepts. So the solutions are there, which is -1 and 3, which match up with the x-intercepts exactly. All right, moving on. We have a couple of more to graph. I'm going to graph and show you the correct answers now. All right, for this first one, you know that the vertex is 0, 8. That's the turning point. The x-intercepts are -2, 0, and 2, 0. Sorry for my little sloppy drawing here, but trust me, it's supposed to be there. The axis of symmetry is x equals 0 because the x value of the vertex is 0. The domain is all real numbers, as you could probably have guessed. The range is y is less than or equal to 8 because all the y values are starting at 8 or less. The function is increasing from -infinity up until 0, and we know that this is the 0 because the axis of symmetry is going to have the same value as this, right? X equals 0 is where it turns, where it stops increasing and starts decreasing, right? From 0 to positive infinity. Last but not least, the maximum and minimum values. The maximum value is 8, right up here, but there's no minimum because it keeps going forever. And then the solutions are -2 and 2. Those are also known as the x values of the x-intercepts. All right, that was the first parabola. Now let's take a look at the second parabola. Okay, notice that this parabola doesn't fully land on the graph. We can't see this part of it, but that's okay because we can figure it out from the graphing calculator. For example, the first question says, where's the vertex? Well, the vertex is down here somewhere. It's going to be either the highest or lowest y value, and in this case, we could tell that it's going to be the lowest y value, right? That vertex is going to be down here. So my lowest y value is -16, so the vertex is -2, -16. Also know that the x-intercepts are -6, 0, and 2, 0 because those are where we touch the x-axis. We can see those on this graph. The axis of symmetry, of course, is x equals -2 because that's the x value of the vertex. Even though we can't see where it touches the y-axis here on the graph, we know that the y-intercept is going to be 0, -12 because that's where the x value is equal to 0. Where x is 0, that's the y-intercept, so 0, -12. Moving on to the domain range. Well, guess what the domain is? Hopefully you guessed that the domain is all real numbers because it's basically always all real numbers. And y is greater than or equal to -16 because -16 is the smallest y value there is. It doesn't go below there. Now we have to figure out where it's increasing and decreasing, and remember that number is going to be based on where the axis of symmetry is. In this case, the axis of symmetry is -2, so it's going to be increasing from -2 to positive infinity, and it's going to be decreasing from -infinity to -2. All right, now we have to identify the maximum and minimum. The minimum in this case is the y value that's the smallest, which is -16. And there is no maximum because it keeps on going forever upwards. So no maximum. And just like every other case we've dealt with, the solutions are based on the x-intercept. So the first solution is -6, and the second solution is 2. All right, hope that was helpful. This is the video on, go away calculator, we're done here. This was the video on the quadratic functions review. Good luck studying.